Real-time geolocation is behind some of the most awesome apps in the world, such as Uber, Instagram, and Waze, to name a few. But building these features from scratch requires a lot of complex math and advanced data modeling. But fortunately, there's tools we can use to build features like this without any trigonometry, and we can do it in the next few minutes. If you're new here, like and subscribe, and if you're serious about building apps like this, consider becoming a pro member at angularfirebase.com. Our goal today is to use Firestore and Angular Google Maps to build a real-time geolocation feature. So we'll be able to say, give us all the documents that are within X kilometers of some center point and have that query update in real time. But before we get going, I have a couple examples of real-world Angular Firebase apps that use geolocation features. The first one is Cypherlinks, which was built by an Angular Firebase Pro member and is essentially a LinkedIn for coders that allows you to find programmers geographically based on a filtered set of criteria. And the next one is podmap.org, which is an open source project using Angular and Firebase that allows you to locate podcasts from around the world. Check out those links in the description, but the next thing I want to talk about is how geoqueries actually work, because they're a lot different than a normal query that you would make in Firestore. So we create this fractal pattern where we have a grid of numbers and letters that segment the globe. Then we can build out a string value by repeating this pattern over and over again inside of each cell. So every additional character in the string will be an additional level of precision for the location. We're going to be saving our geohashes as 9 characters, which is precise to about 4.5 meters squared. If you go to movabletypes.org, you can explore the bounding boxes for different geohashes. If we want to query Firestore for all of the documents inside of a single geohash, it's actually pretty straightforward. We can set the starting point as the geohash, the endpoint as the hash plus a high Unicode character, then we can order by the property that has that hash, and then do start at, end at. But here's the problem. Let's imagine Kathy and Tim are next door neighbors, and Tim does a search within this geohash. Even though Kathy's right next door, he's only going to get results inside of his geohash. So to get the true results, you would have to get all of the neighboring geohashes as well, and then draw a radius around them to find anything within that radius. And there's a bunch of other little edge cases that you'll run into as well, which is why I decided to just create a library that handles all this stuff under the hood. It's called GeoFireX, and it uses RxJS and Firestore to make these queries possible. But don't worry, I didn't do any of the trigonometry myself. I left all that to an awesome library called TurfJS, and it's compatible with both flat Earth and round Earth theories. It's also compatible with any JavaScript framework as long as it's using Firebase and RxJS. Let's go ahead and get started from a brand new Angular app, and then the first thing we'll do is install the Angular Google Maps package, which is a great component library if using Google Maps. From your Firebase project, you can go to the Google Cloud Platform console and enable the Google Maps JavaScript API. From there, we can install Angular Google Maps in our app, as well as Firebase and GeoFireX. Now, at this point, if you're using Angular or Ionic, I would recommend using the Angular Fire 2 library, but the bare minimum thing you need to do is just initialize a Firebase app. So that should look something like this code here. Then you'll also want to initialize Angular Google Maps with your API key, which you can do here in the app module. Now let's create a basic map with AGM, which is super easy. The first thing we'll want to do is go into our CSS and make sure we give it a width and height of something other than 0. Otherwise, you won't be able to see the map at all. After that, we can just declare an AGM map component and give it a starting latitude and longitude point. We can also drop in a marker and give it a latitude and longitude as well, and that will just pop up on the map at that point. What we'll do next is loop over a collection of documents in Firestore and render them on the map as these markers. One of the special things that GeoFireX does is that it saves data in a format that can be queried. In order to make geoqueries, you need to have an object on the document that contains a geohash and a geopoint. The library will format this for you automatically, but you can save multiple geopoints on a single document, so you can do geoqueries against multiple parameters. So let's go ahead and make a query against this existing dataset. I'm going to go ahead and import GeoFireX as well as our Firebase app. Then we can initialize GeoFireX by passing it a reference to our Firebase app. And then we'll also declare a property called points, which is an observable of the actual documents that we query. There are several variables that are needed to make a geoquery. The first one is your center point, which can just be a latitude and longitude. You can create a geohash with the library by calling the point method. It can do a bunch of other things like return GeoJSON and calculate distance and bearing and things like that. Then the next variable that you'll need is the radius that you'll draw around the center point, which will always be in kilometers. Under the hood, the library uses turf.js to calculate the haversine distance, which also takes into account the curvature of the Earth. And lastly, we need to specify the object that contains the geodata, because remember, a single document can have multiple geopoints that can be queried against. Then the next thing we do is make a reference to the Firestore collection. This is just a wrapper for the main SDK that provides some additional functionality for geolocation. To perform a geoquery, you can use the within method that will take in the center, radius, and field. And that returns an observable that you can just subscribe to, and it will stay in sync with any changes that happen in real time to that collection. But because we're using RxJS, we can do this in a little bit more of a dynamic way. For example, let's say the user clicks a button that will expand the radius to a different value. For that, we could set up the radius as a behavior subject, which itself is an observable that can have new values pushed to it. Then we'll define our observable points as the radius behavior subject that is then switch mapped to the actual observable geoquery. And I would like to point out that within returns a hot observable that is cached to the last value. That means you can have multiple subscribers to it, and you will only be charged for the initial document read. So by setting this up with switch map, we can now change the radius and get a whole new query each time the user clicks a button. For example, we just need to call radius next, and everything else will change reactively. Now we need to unwrap the observable of our locations. In Angular, we can do this very conveniently with the async pipe, but in other frameworks, you'd want to call subscribe on the observable and handle it accordingly. Inside of our AGM marker, we'll do an ng for loop, and we'll loop over each point of points using the async pipe to unwrap it, because it returns an observable array of document data. This gives us access to all of the data on each document, but it also returns some additional metadata that's specifically designed for building real-time map features. For example, it returns the distance and bearing that this document was found at relative to the query center point, which can only be figured out at runtime. You might query a collection of restaurants that are relative to a user's current GPS position on their phone, and the query metadata gives you the information needed to show the distance to that point to the user in the UI. And that will be by default on the query metadata on the returned points. I have a pre-made demo that I use for integration testing, and every point in the document is a specific distance and bearing from the center. And the actual gray circle is the radius of the query. And if we click on any of these points, we'll also see the query metadata, which again is the distance and bearing. What's really cool about Firestore is everything is just real time by default. So imagine we have one of these documents that are being written to every couple seconds as the user's position moves. It will update in the UI like we see happening here with the blue marker. But as soon as it falls out of range, it disappears from the query and also the UI. There's a bunch of other little features that I've added to GeoFireX specifically for working with tools like Mapbox and Google Maps. If you find it useful, make sure to star it, and please report any issues that you encounter when using it. I'm going to go ahead and wrap things up there. Thanks so much for watching, and I'll talk to you soon.